Okay, let's go over the test. Now, this one clearly, well, to me, clearly could be done with u sub. If I let u equal x squared minus 1, then du would be 2x dx, and dx would be du divided by 2x. And that x will cancel that x. So this would become the integral of x dx is du over 2x. And we have the square root of u, which is u to the 1/2. Okay, and if we have that, the x's cancel, and the 2 in the denominator would come out as 1/2 the antiderivative, the integral of u to the negative 1/2. U to the 1/2 in the denominator is u to the 1/2 in the numerator. And the antiderivative, I add 1 to this power, which makes u to the 1/2, and divide by the new power. And I've got times 1 over 2 plus c. And the 2 times 1/2 is 1, so I just get the u to the 1/2, or the square root of u. So this is the square root of x squared minus 1 plus c. So that's what the answer is. But that's not using one of the methods we need to do. Now this one looks like it could be done with trig sub. So we'll do a triangle and theta. And this is x squared minus 1, so I'm going to have to put, this is the positive part, this is the negative piece, so I'm going to put x on the hypotenuse, and I can put the square root of 1, which is 1. I can put 1 on either side. Doesn't matter. In fact, I think I'll do it both ways. If I put 1 here, this side becomes the square root of x squared minus 1. If I do it this way, then x would be hypotenuse over opposite, or the reciprocal of sine, so it's cosecant of theta is x over 1, or x. Then I take the derivative, and I get the derivative of cosecant of theta is negative cosecant theta cotangent theta d theta, and that will be the derivative of x, which is 1 dx. And I need this square root thing, so I can replace that with that to 1. That's the cotangent of theta is the square root of x squared minus 1. That's adjacent over opposite instead of opposite over adjacent, which is tangent. So this integral would change to, I have an x, which is cosecant. I have a dx, which is negative cosecant theta cotangent theta d theta over, and I have the square root thing, which is cotangent theta. Cotangents cancel, and so I have a negative cosecant squared, and the antiderivative of cosecant squared is cotangent. Antiderivative of negative cotangent, cosecant squared is cotangent. So with the negative on this is cotangent theta, And cotangent is square root of x squared minus 1. So this is worked with trig sub. It doesn't work with partial fractions. It would be messy to try to do it with parts, and I don't know that there's anything on our table for that. Now, I said I was going to do this one both ways. So I'm going to do this one with putting the x still has to be on the hypotenuse because that's the positive thing, and I'm going to put 1 on the adjacent side. That means the opposite would be x squared minus 1. And so now the secant of theta is x. Derivative is secant theta tangent theta d theta, derivative of this side, equals the derivative of this side. And what does this equal? Let's see, opposite over adjacent is the tangent, is the square root of x squared minus 1. So our integral becomes, our x is secant, our dx is secant tangent, d theta, and this denominator piece is the tangent. So the tangents cancel. So I got secant squared, and the derivative of tangent is secant squared, so the antiderivative of secant squared is tangent. But now we're got to get back to x's, and the tangent is that. And all three of them give the same answer, so that's a good sign that we're probably doing it right. I had several people say, well, I don't know what to do with this one. This is addition. You've done integrals of like x squared plus 2 dx. You do this part and you do this part. When they're added or subtracted, you just do the separate pieces. So this is the integral of secant cubed x dx plus the integral of sine to the 4th x dx. Now there's probably several ways to do this one and that one, but it's going to be messy, so let's just use the table on this one. So secant to the 3rd. Well, here's secant to some power turns into this. So let's see if I can get this in a place where I can do it. That'll work. So this first one becomes, let's see, m was 3, so that's tangent x. 2 less than 3, so it's 1 secant x over 3, m is 3, 3 minus 1 is 2, plus 3 minus 2 is 1, 3 minus 1 is 2, so 1/2. Another integral. And this would be, if this was 3, 3 minus 1, this would be the antiderivative of secant. Let's see, the antiderivative of secant's up here. So it'd be ln secant x plus tangent x. ln, absolute value of secant x plus tangent x in the absolute value. And all this would be plus c, but there's going to be a plus c on this, so I'm just going to do 1 plus c at the end. So now let's do the sine to the fourth. Well, this is sine, cosine, sine, cosine. Here is sine to any power. So there you can see all of it. So it becomes, our n is 4, so we got sine to the third. And there's, oh, a minus there. So I better be careful here. It's going to be minus everything I get here. And sine to the fourth is sine of 1 less than 4, so sine to the third x cosine x over n, which was 4. That's the part that's minus. So I'm going to go plus and make this minus inside. And then we have plus n minus 1. So 4 minus 1 is 3. Over n, 4. Antiderivative of sine squared. So I'm going to go right to what is the sine squared? That is x over 2 minus 1/2 sine x cosine x. And then that's all of this plus c. Okay. Page 2. Well, there's a product here, and the best way to undo products is by parts. And normally we'd let u be this, and it would decrease from x to the fifth to x to the fourth. But if there's an ln involved, then u becomes the ln, because we don't like to do the antiderivative of ln. So if I let u be ln x, then its derivative is 1 over x dx. So then if I'm letting this be u, the derivative x to the fifth, the derivative of v is x to the fifth dx. Taking the antiderivative, we get 1/6 x to the sixth. So this becomes uv, so 1/6 x to the sixth ln x. This should have been an absolute value, but it wasn't here. So we have to assume that x is greater than or equal to 0, so we don't have to worry about that. Minus the antiderivative, the integral of not these two, but these two. So that's 1/6 x to the sixth times 1 over x dx. Well, this x will cancel one of these x's, and then 1/6 can be pulled out. So I have 1/6 x to the sixth ln x, since the positive I don't need the absolute value, minus 1/6, and x to the fifth integrated would be x to the sixth divided by 6, plus c. So that's 36 under the x to the sixth, or 1/36 x to the sixth. But that's it. This one, u sub does not work very well on this one. And I'm going to guess that some people try to do by partial fractions. So I'm going to just show you what happens if we do this one by partial fractions. So we've got a quantity that does not factor. So we'd have to go ax plus b because it's squared. And we'd have x squared plus 1, a quadratic factor, so we do a linear numerator, plus, and since that factor happens twice, we'd have to do it with that thing with a cx plus d. Again, a quadratic factor, but it's happening twice, and so you do it single and the squared. So this is where I'd have to use my deal. So to get a common denominator, I'd have to take this one times x squared plus 1, and this one times nothing because it already has the common denominator. So now if I make my equations, I'm going to have some x to the thirds, x to the seconds, x to the first, and a constant. X to the thirds, none. Ax times x squared is ax to the thirds. Ax times that's x, that's a bx squared. There's no other x to the third, so that's it. A has to be 0. X squareds. Ax times 1 is not x squared, but b times x squared is 1, so I got b. And how many x squareds do I have over there? 0. So I got 0 equals b plus, how many x squareds do I have here? None. Oh, so b has to be 0. And c, the x's, there's none. So 0. How many x's here? Well, we have ax times 1, so we have a number of x's. And we have b times x squared. Nope. B times 1. Nope, that's not an x's. And so there's no more x's here. And over here we got c. So a plus c has to be 0. And then we got one constant. And that has an x, so it's not going to have anything to do with the x's. This times x, this ax times x cubed is ax to the third. The only way you get a constant is b times 1, which is b. And here we got plus d. So a is 0. So this integral would change to two integrals. A is 0 and b is 0. Oh, this whole fraction is 0. So that would be gone. And let's see, a plus c is 0, and if a is 0, c must also be 0, so this is 0. And if b is 0 and b plus d is 1, d must be 1, and so it becomes the integral of 1 over x squared plus 1 squared dx. Oh, that's what we had to start with. So this doesn't work. Doing partial fractions doesn't get us anywhere. But trig sub would. Parts doesn't. Partial fraction doesn't. You might find something like this in the table, but it's really a trig sub problem. And these are added. So I'm going to make my triangle with the hypotenuse, the square root of x squared plus 1. And I could put x here or here and 1 the other place. So I'm just going to put the x there and 1 there. And if I do it that way, the tangent of the angle is x. X over 1 or x. Taking the derivative, we get secant squared theta d theta equals dx. And we need something for this, and so that over 1 is the secant. Theta is that over 1. So, doing the trig sub, this integral becomes 1, we can leave. Dx is secant squared theta d theta. And this is secant squared, because if I square this, get rid of the square root. Secant squared is this, and it's squared. So I got secant squared squared, or secant to the 4th theta. 2 of the secants cancel 2 of the secants. So I have the integral of 1 over secant squared. Well, 1 over secant is cosine, so I have cosine squared theta d theta. And cosine squared is x over 2, so but the angle is it's theta, so it's going to be theta over 2 plus 1/2 sine theta cosine theta plus c. So now we got to get back to our x's. Theta, if I solve for theta, it's going to be the arctangent of x. That's theta divided by 2 plus 1/2. The sine is x over that. Times the cosine, which is 1 over that. These multiply out to be just 1/2 x over the square over x squared plus 1. If we take a square root times itself, it gets rid of the square root, and we get that. So we get arctangent so we get that. Oh, didn't show. Arctangent of x over 2, 1/2 x over these multiply, get rid of the square root, plus c. 3. Well, we haven't done partial fractions yet. This wouldn't work very well for parts. It wouldn't work very well for trig sub because it's not looking like squared minus squared. Might be something in the table, but we need to show partial fractions, so I'm going to factor the denominator. And I see there's an x squared in both parts, and that leaves an x minus 4. So I'm going to get the partial fractions. See, x squared, that means I'm going to have to do x, a linear term, plus an x squared when it repeats itself. So that's a b. It's still a linear factor, but it's repeated. Plus that we have a x minus 4, another linear factor. So that's a c. To get a common denominator, this one needs an x and an x minus 4. So x times x minus 4 is x squared minus 4x. This one has an x squared. All it needs is an x minus 4. Numerator, denominator. This one just needs an x squared. So we have some x squareds. We have no x squareds. So 0 equals ax squareds, no x squareds, and plus c. That's the x squareds. Now we're going to go to the x's. There's none there. There's ax squareds. Oops, I'm doing x's. Minus 4ax's plus b x's and no other x's. And constant, we have 3. We have both of these have x's, so no constants there. We get minus 4b and no x's there. So b has to be divided by -4, -3/4. If b is -3/4, I can add it to the other side, then divide by -4, and I get a has to be -3/16. And if a and c add to be 0, c must be +3/16. So this becomes the integral of -3/16 over x plus -3/4 over x squared plus 3/16 over x plus 4. X minus 4. Well, this comes out, and we got the integral 1 over x, so we get -3/16. The integral of 1 over x dx is ln absolute value of x plus c, but we'll take care of the c at the end. This is -3/4 pulls out, and this is x moving the x in the denominator. It's x to the -2. If I integrate it, it goes to x to the -1, which is 1 over x, divided by -1, which changes this to plus. And this one with a u sub equal to x minus 4, du equals dx, and so this becomes 3/16 antiderivative of 1 over u, which is ln absolute value of u, which is x minus 4, plus the c. Six. So if we're not have the integral sign, we need to integrate this. This is a great candidate for u, because the derivative is going to produce a 2t that's going to end up under the du. So now I have the antiderivative. I'm changing the variable to u, so I don't know what 1 is or x is. I'll talk about that in a sec, but we have a t. We have cosine of u, and dt is du over 2t, The t's cancel. The 2 in the denominator pulls out, and it becomes 1/2 the antiderivative of cosine u du, which is sine u. This is a definite integral. Don't know what the limits are here. Let's just talk about that. If x is 1 and u is this, 1 squared is 1 plus 2 is 3. So the new limits are 3, 2. X in here, x in here, for the t would be x squared plus 2. So u would be x squared plus 2. So this would be x squared plus 2. And I could put in x squared plus 2 into here, minus 1/2 sine of the bottom was a 3. So we get 1/2 cosine of x squared plus 2 minus 1/2 sine of 3. And no plus e because it's a definite integral. Okay, 7. We're going to take the derivative first. So whatever that is, there won't be any constants created. And then when we do the antiderivative, we'll go back to this function. And we got to plug in the x. So we're going to get sine x ln x minus, then we got to put in the 3. So it's the sine of 3 ln 3. Now, if we integrate this first, then we're going to, whatever the antiderivative of this is, we're going to find f of it with an x put in minus f with a 3 put in it. Whatever the antiderivative of this is, we're going to get this, that we have to take the derivative. So the derivative of f takes us right back to here with an x in it. So it's sine x ln x minus the derivative of f with 3 in is just a constant. Derivative of that's going to be 0. So we're done with just that. On this one, at 2, 4, 6, we're supposed to be at 4, 8, 12. At 6, we're supposed to be, we have positive area going forward, so this function is going up. The area is, let's see, this is 1 high and 2, 4, 6, so it's 6, 8, 10. It is 4 by 1 in half, which is 2. So by 10, we've got to be up 2 more. Since each of these is 4, 2 more would be in the middle. And that's where the slope is 0. And before that, it was positive. This is above the x-axis, it's positive, getting less and less positive. And then if we go to 14, it looks like that'll just cancel what we just gained, so it should take us right back down to here. Same line, so same kind of curvature. And then we've got this to add on. That's 1 1/4 squares, and each square is 2 by 1, 2. 1 the squares would be 1, and another quarter be a half. So it's 1.5 I need to come down. 2 would be in the middle, 1.5 not quite as far by 16. Oh, so I'm pretty close to 12, 10, 11. So, choo. Now, over here, each of these squares is worth 2. 2 wide, 1 tall, 2. So I got to be going up with a slope of 2. So here I'm at 8. And if I go up 2 for, see, this is 2 across. So for 1, it'd be just halfway. I got to go up 2. This is 8, 12. So 2 up is a 10. And over 1. So I'm about there. And it's continuing here. This is up 2 for 1. Up 4 for 2. 4 for 2, or 2 for 1. 2 for 1. So it would go like this, clear back to minus 12. And then it drops in steepness and bottoms out at 14. And then it starts going back up. Negative area means, it was going up because of the positive area. It's going up. It's going to go, this is negative area, so it has to be losing. So it's coming down to here and hits a bottom, and so it's losing more here than it is there, and so it's curved this way. If I go from negative 14 to negative 16, one box is 2, so that's 1 down. And then I'm going, or it's coming down, so it's got to be 1 above this, so it's about there. Or maybe this was at negative 2, so it's probably about there. And then here we have 2, 3, negative 3, so it's got to come down 3, so that's from someplace up here to there. And this is 2, 4, 2, 4, 5. So it comes down 5, 4, 5, 6, 5. So from there. Okay. And that was the test.